Greetings children. Welcome to the next session of electricity for class 10. This is the fifth part in the series, Ohm's law relationship. Current I equals voltage V upon resistance, R, in amperes, R. By knowing any two values of the voltage, current or resistance quantities we can use Ohm's law to find the third missing value. Ohm's law is used extensively in electronics formulas and calculations, so it is very important to understand and accurately remember these formulas. To find the voltage, V equals I XR, V, volts, equals I, amps, XR, ohm. To find the current, I equals V divided by R, I, amps, equals V, volts, divided by R, ohm. To find the resistance, R equals V divided by I, R, ohm, equals V, volts, divided by I, amps. It is sometimes easier to remember this Ohm's law relationship by using pictures. Here the three quantities of V, I and R have been superimposed into a triangle, affectionately called the Ohm's law triangle, giving voltage at the top with current and resistance below. This arrangement represents the actual position of each quantity within the Ohm's law.
Question 10. A resistance of 20 ohms has a current of 2 amperes flowing in it. What potential difference is there between its ends? Solution: R equals 20 ohms, I equals 2 amp. Let's use the OHM's triangle. We know that V equals I into R, thus, V equals 2 by 20, V equals 40 volts. A current of 5 amperes flows through a wire whose ends are at a potential difference of 3 volts. Calculate the resistance of the wire. Solution: I current equals 5 ampere, potential difference V equals 3 volts. We know that V equals I into R. Use the triangles for reference. Thus, 3 equals 5 into R equals 3 upon 5 equals 0.6 ohm.
Question 12. Fill in the following blank with a suitable word. Ohm's law states a relation between potential difference and solution, current. Question 13. Distinguish between good conductors, resistors and insulators. Name 2 good conductors, 2 resistors and 2 insulators. Solution: those substances which have very low electrical resistance are called as good conductors, e.g. copper and aluminium. Those substances which have comparatively high resistance than conductors are known as resistors, e.g. nichrome and manganese. Those substances which have infinitely high electrical resistance are called insulators, e.g. rubber and wood. Question 14. Classify the following into good conductors, resistors and insulators: rubber, mercury, nichrome, polythene, aluminium, wood, manganese, bakelite, iron, paper, thermocol, metal coin. Solution: conductor a mercury, aluminum, iron, metal coin, resistor, manganese, nichrome, insulator, rubber, polythene, wood, bakelite, paper, thermocol.
What is Ohm's law? Explain how it is used to define the unit of resistance. Solution: Ohm's law gives a relationship between current, I, and potential difference, V. According to Ohm's law, at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its ends. If I is the current flowing through a conductor and V is the PD across its ends, then according to Ohm's law, current I is directly proportional to voltage. You can also say voltage is directly proportional to current. If we use the Ohm's law triangle, we can see that to find voltage we multiply resistance with current. To find the resistance, R equals V divided by I, R, ohm, equals V, volts, divided by I, amps, where R is resistance offered by the conductor which is constant. The unit of resistance is ohm. If V equals 1 volt and I equals 1 ampere, then R equals 1 upon 1 equals 1 ohm. Therefore, 1 ohm is defined as the resistance of a conductor such that when the potential difference of 1 volt is applied to its ends, a current of 1 amp flows through it. What is meant by the resistance of a conductor? Write the relation between resistance, potential difference and current. Solution: A. The property of a conductor due to which it opposes the flow of current through it is called resistance of the conductor. Work done equals potential difference x charge moved. B. When a 12V battery is connected across an unknown resistor, there is a current of 2.5 mA in the circuit. Calculate the value of the resistance of the resistor. Solution: B, V, volts, equals 12 volt, I, current, equals 2.5 mA. 1 mA is equal to 1000 amperes. Therefore 3.5 into 10 raised to 3 amperes. We know that V equals I into R if we follow the Ohm's triangle. R equals V upon I. R equals 12 upon 2.5 into 10 raised to 3, R equals 4.8 into 10 raised to 3 ohm equals 4800 ohm.
Question 17. Define the unit of resistance, or define the unit ohm. What happens to the resistance as the conductor is made thinner? Keeping the potential difference constant, the resistance of a circuit is doubled. By how much does the current change? Solution: 1 ohm is the resistance of a conductor such that when a potential difference of 1 volt is applied to its ends, a current of 1 ampere flows through it. B. Its resistance will increase. C. Voltage equals I into R. Keeping V constant, I is inversely proportional to R. So when R, that is resistance, is doubled, I, that is current, becomes half. Question 18. Why do electricians wear rubber hand gloves while working with electricity? B. What PD is needed to send a current of 6A through an electrical appliance having a resistance of 40 ohms? Solution: Electricians wear rubber hand gloves while working with electricity because rubber is an insulator and protects them from electric shocks. B. I equals 6 amp, R equals 40 ohm. We know that V equals I dot R. V equals 6 by 40 equals 240 V. An electric circuit consisting of a half a meter long nichrome wire C, an ammeter, a voltmeter, 4 cells of 1.5 V each and a plug key was set up. I draw the electric circuit diagram to study the relation between the potential difference maintained between the points X and Y and the electric current flowing through C. 2. Following graph was plotted between Y and L values using above circuit. 2. Following graph was plotted between V and L values. 2. Following graph was plotted between V and L value. Following graph was plotted between V volts and I current values. At the potential difference of 0.8 volts. V upon I. 8 upon 3. Finding 1. At a potential difference 1.2 V. V upon I. 1.2. 0.45 is equal 8 upon 3. Finding 2. At potential difference 1.6 V. V upon I. 1.6. Upon 0.6. Finding 3. Conclusion: if 1 be the current through C resistor and V be the potential difference across it, then the ratio V upon I equals constant. Equals greater than V directly I and Ohm's law is obeyed. What is the ratio of potential difference and current known as? Solution: the ratio of potential difference and current is known as resistance. Values of voltage should be plotted on the y-axis and values of current should be plotted on the x-axis. Values of voltage should be plotted on the y-axis and values of current should be plotted on the x-axis. According to Ohm's law, R resistance equals V volts upon I current. From the graph, resistance, R equals V volts upon I current. R equals 5 upon 0.2 equals 25 ohm. C. Name the law which is illustrated by the above V minus I graph. Solution: Ohm's law is represented through 5 and 1 graph for a conductor. Since the graph is a straight line, we can conclude that V is directly proportional to I. Ohm's law states that at a constant temperature, the current passing through a conductor is directly proportional to the potential difference applied across it. Write down the formula which states the relation between potential difference, current and resistance. According to Ohm's law, I equals V upon R. This gives the relation between potential difference V, current I and resistance R. According to Ohm's law, R equals V upon I. R equals 240 upon 5. So we get, resistance R equals 48 ohm.
An electric room heater draws a current of 2.4 A from the 120 V supply line. What current will this room heater draw when connected to 240 V supply line? Solution: in first case, I current equals 2.4 ampere, V equals 120 volt. V equals I into R. 120 equals 2.4 into R. R equals 120 by 2.4 equals 50 ohm. In second case, V equals 240 volt. R equals 50 ohm, V equals into R 240 equals I into 50, I equals 4.8 amp. Question 31. Name the electrical property of a material whose symbol is omega. Solution: resistance. Question 32. The graph between V and 1 for a conductor is a straight line passing through the origin. Which law is illustrated by such a graph? What should remain constant in a statement of this law? Solution: A. Ohm's law. B. Temperature. Question 33. A potential difference of 10 V is needed to make a current of 0.02 A flow through a wire. What PD is needed to make a current of 250 mA flow through the same wire? Solution: in first case, I equals 0.02 ampere, V equals 10 volt, V equals I into R. 10 equals 0.02 into R equals 10 by 0.02 equals 500 ohm. In second case, I equals 250 into 10 raised 3 ampere, R equals 500 ohm, V equals I into R. V equals 250 into 10 raised to 3 into 500, V equals 125 volt. Question 34. A current of 200 mA flows through a 4 kΩ resistor. What is the potential difference across the resistor? Solution: I equals 200 mA 1 upon 1000 of an ampere, a measure for small electric currents, equals 0.2 ampere. R equals 4 into 103 ohm equals 4000 ohm. We know that V equals I into R. V equals 0.2 by 4000, V equals 800 volts. Question 1. What happens to the resistance as the conductor is made thicker? Solution: the resistance decreases. Question 2. If the length of a wire is doubled by taking more of wire, what happens to its resistance? Solution: resistance also gets doubled. Question 3. On what factors does the resistance of a conductor depend? Solution: resistance of a conductor depends on the following factors: length of the conductor, area of cross-section of the conductor, nature of material of the conductor, and temperature of the conductor. Question 4. Name the material which is the best conductor of electricity. Solution: silver metal. Question 5. Which among iron and mercury is a better conductor of electricity? Solution: iron. Question 6. Why are copper and aluminium wires usually used for electricity transmission? Solution: because copper and aluminium have very low resistivities. Question 7. Name the material which is used for making the heating element of an electric iron. Solution: nichrome. Question 8. What is nichrome? State its one use. Solution: nichrome is an alloy of nickel, chromium, manganese and iron having a resistivity of about 60 times more than that of copper. It is used for making the heating elements of electrical heating appliances. Question 9. Give 2 reasons why nichrome alloy is used for making the heating elements of electrical appliances. Solution: nichrome alloy is used for making the heating elements of electrical appliances because I. Nichrome has very high resistivity. 2. Nichrome does not undergo oxidation, or burn, easily even at high temperature. Question 10. Why are the coils of electric irons and electric toasters made of an alloy rather than a pure metal? Solution: because I. Resistivity of an alloy is much higher than that of a pure metal. 2. An alloy does not undergo oxidation, or burn, easily even at high temperature. Question 11. Which has more resistance? A. A long piece of nichrome wire or a short one? B. A thick piece of nichrome wire or a thin piece? Solution: A. A long piece of nichrome wire. B. A thin piece of nichrome wire. Question 12. A. How does the resistance of a pure metal change if its temperature decreases? B. How does the presence of impurities in a metal affect its resistance? Solution: A. On decreasing the temperature, the resistance decreases. B. Presence of impurities in a metal increases the resistance. Resistance is measured in ohm. The resistance of a wire increases as the length increases, as the temperature increases, and as the cross-sectional area decreases. Question 14. A. What do you understand by the resistivity of a substance? Solution A. Resistivity is the characteristic property of a substance which depends on the nature of the substance and its temperature. It is numerically equal to the resistance between the opposite faces of a 1 meter cube of the substance. B. A wire is 1.0 meters long, 0.2 millimeters in diameter, and has a resistance of 10 ohms. Calculate the resistivity of its material. Answer given the length of the wire, L equals 1 meter diameter of the wire, D equals 0.2 millimeters so the radius of the wire, R equals 0.1 millimeters equals 0.0001 meters area of a cross-section of the wire equals area equals pi r square equals 3.14 into 0.0001 raised to 2 equals 3.14 into 10 raised to minus 8 meters square. Resistance of the wire, R equals 10 ohms. So resistivity equals ρ equals R into A by L. Therefore, ρ equals 3.14 into 10 raised to minus 7 ohm m. Thus, the resistivity of the material, ρ equals 3.14 into 10 raised to minus 8 ohm m. A. Write down an expression for the resistance of a metallic wire in terms of the resistivity. B. What will be the resistance of a metal wire of length 2 meters and area of cross-section 1.55 into 10 raised to minus 6 m square, if the resistivity of the metal be 2.8 into 10 raised to minus 8 ohms m? Solution A. The resistance of a metallic wire in terms of resistivity is given as, additionally, the resistance is inversely proportional to the cross-sectional area A. R equals constant 1 upon area. Here, ρ is the resistivity of wire, L is the length, A is the area of cross-section and R is the resistance of wire. B. What will be the resistance of a metal wire of length 2 meters and area of cross-section 1.55 times 10 raised to minus 6 meters square, if the resistivity of the metal be 2.8 into 10 raised to minus 8 ohms m? Length equals 2 meters. Area equals 1.55 into 10 raised to minus 6 meters square. ρ equals 2.8 into 10 raised to minus 8 ohm meter. R equals ρ1 upon area because the resistance is inversely proportional to the cross-sectional area A. Equals 2.8 into 10 raised to minus 8 ohm meter into 2 bushels 1.55 into 10 raised to minus 6. Equals 0.036 ohms. Q16. A. Give 2 examples of substances which are good conductors of electricity. Why do you think they are good conductors of electricity? B. Calculate the resistance of a copper wire 1.0 kilometers long and 0.50 millimeters diameter if the resistivity of copper is 1.7 times 10 to 8 omega m. Answer A. 2 examples of substances that are good conductors of electricity are silver and copper. These 2 metals have free electrons that are available for conduction. B. Given in question, L equals 1 kilometer equals 1000 meter. Radius equals diameter by 2. Since diameter equals 0.50 millimeters diameter equals 0. 5/2 of a millimeter equals 0.25 millimeters equals 0.25 into 10 raised to minus 3 meter. Ρ equals 1.7 into 10 raised to minus 8 omega meter. We know that R equals ρ into L upon area. R equals 86.6 omega. Question 17. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Give reason for your answer. Solution. Current will flow more easily through thick wire because the resistance of the thick wire will be lesser than that of thin wire. Question 18. How does the resistance of a conductor depend on A. Length of the conductor, B. Area of cross-section of the conductor, C. Temperature of the conductor? Solution. A. Resistance of a conductor increases, or decreases, with increase, or decrease, in the length of the conductor. B. Resistance of a conductor decreases, increases, with increase, decrease, in the area of cross-section of the conductor. C. Resistance of a conductor increases on raising the temperature and decreases on lowering the temperature. Question 19. A. Give one example to show how the resistance depends on the nature of material of the conductor. B. Calculate the resistance of an aluminium cable of length 10 km and diameter 2.0 mm if the resistivity of aluminium is 2.7 × 10⁻⁻⁸ ohms meter. Solution. A. If we take two similar wires of same length and same diameter, one of copper metal and other of nichrome alloy, we will find that the resistance of nichrome wire is about 60 times more than that of the copper wire. This shows that the resistance depends on the nature of material of the conductor. B. Diameter equals 10 km. Equals 10 × 10⁻⁻³ D equals 2.0 mm. Radius R equals 1 mm equals 1 × 10⁻⁻. Cross-sectional area area equals pi r square. Equals pi × 10⁻⁶ meter square. So resistance equals ρ × 1 upon area. Equals 2.7 × 10⁻⁸ × 10⁴ upon ohm × 10⁻⁶ ohm. R equals 85.98 ohms.